Hi friends, this is Novita. Today we are discussing about heat and temperature. Today in the class we will cover heat, units of heat, specific heat, heat transfer modes and conductors and insulators. Shall, shall we move into the class? Yes. What is heat? Have you observed that in summer you feel very hot, but in winter you feel cool, right? So what happening in the summer and the winter, why you had that feeling of hot and cold, right? So due to the difference in the heat, right? And if you take any water bottle from the fridge, if you hold it, so after few minutes, yes, you after few, not in minutes also, even in seconds, you feel that your hand is having that coolness. How your hand is having that coolness? That means there is a transfer between them, right? So now today we will discuss about the heat. Heat is a form of energy. Form of energy. It's a form of energy which transfers from hot body to cold body. So you may have doubt that why ma'am written as hot body to cold body. Heat will not transfer from cold body to hot body. No. Always heat transfers from cold body to always heat transfers from hot body to cold body. It never transfers from cold body to hot body. So if I take the two objects, right? One is hot, other one is cold. So how the heat transfers? Heat will be transformed from hot body to cold body. Only one way direction. So how long that heat will transfer? That is a question. Think that if the hot body is having 100 degrees centigrade, for example, and the cold body is having 20 degrees centigrade, right? This heat will transfer to the cold body until the both bodies attain same temperature. Until the two bodies attain same temperature, the heat will be transferred continuously. It transfers until the same temperature is attained, right? So think that if 100 degrees centigrade body is made contact with a 20 degrees centigrade body and heat is transferring, slowly this 100 degrees is reduced to 80 degrees centigrade and again it reduced to 70 degrees centigrade. Here the 30 degrees is increased, 20 degrees increased to 30, 30 increased to 40. Again here 70 will be reduced to 60. If it is 60, that 10 degrees is transferred to this body. How much it will happen? 50 degrees. And again if you think that it reduced to 50 degrees, so it will be of 40 degrees. So it will not happen. So if it reaches 55 degrees, it also if reaches to 55 degrees, the heat transfer will stop. So that means if it reached to 55 and if it reached to 55, same temperature until same temperature attains, the body will continuously transfers the heat to the cold body like this. Take one body is always giving, other body is taking until Both is having the same temperature. This is your heat. Now, what question is why? Why heat is transferred? So we observe that yes, heat is transferred, and we also observe that always heat is transferred from hot body to cold body. Ma'am, I have a doubt that if I take any ice cube and if I place on my palm, right? After some time, I feel my body will feel cold. But you said that always heat transfers from hot body to cold body, right? See, when I place ice cube on my hand, right, slowly my heat, whatever the temperature of my body, will be transferred to the ice cube. Slowly. What happens? Slowly the ice will melt because it increases the temperature, it absorbs the heat, that's why it will melt, and by the time even my body is decrease the temperature, right? That happens. That's why we feel cold and ice will melt after a few minutes. Now, why heat is transferred is a question. So already you know that always a matter exists in three states: solids, liquids, gases. But what is a matter? It's a molecule, right? Whatever the molecules that are combined together called molecules. That means if I take any body, that may be solid, that may be liquid, that may be gas. If I go for internal structure, so see, these are the molecules, right? And so this is the arrangement of molecules. If this arrangement is so closely packed, that is called solid structure. If they are loosely packed when compared to solid, that is called liquid. If it is very loosely packed, very far from each other, then it is gas. Solid, liquid, gas. Have you seen difference between solid, liquid and gas? Yes. In solids, whatever the molecules are tightly packed, here they are loosely packed and here they are very loosely packed. Here, why they are tightly packed means in solids because more intermolecular force. Intermolecular force. So whatever the force between these two molecules or any two molecules we call intramolecular force. So they will hold like this. So see, if I want to pull like this, yes, I cannot easily. Why? Because there is a bond here that we call intramolecular force. Similarly, the solid, whatever the molecules will combine with each other, that force will make them to be in a nearer to each other, right? So more intramolecular force and less intermolecular space. Intermolecular space, right? So if I take the two molecules, always the two molecules will pull both each other. This we call intramolecular force. And whatever the gap between the two molecules, we call it as intramolecular space, right? Intermolecular space, intermolecular force. Now, so in any, that may be liquid, that may be gases, yes, even there is a gap. This is intermolecular space. Whatever the attraction between the two molecules is called intermolecular force. Even in gas also, this is your intermolecular space and this, the force is attracting each other. So now, suppose, think if it is a solid. If I increase the temperature, what is the meaning of increasing temperature? That means I am giving the heat. Now, if I give the heat, what happened? The body will absorb the heat. Heat is absorbed by the body. If the heat is absorbed, obviously the molecules will attain kinetic energy. That means they will vigorously, they want to move from each other. that kinetic energy will make the molecules to move far from each other. Have you observed the key in your home? Right? So first how it will be? It will be in a solid state or semi-solid state. If your mother applies some heat, the ghee will be melted and it will become a liquid. Right? Have you observed it? Why? If I am giving heat, this absorbs the heat and the molecules will move far from each other. So that solid will become liquid. Right? Similarly, why they'll move? Because they'll attain kinetic energy by absorbing heat. If I absorb heat, yes, I'll attain a kinetic energy. That if I am a molecule, so I'll try to move. By the movement, they'll move far from each other. And by that, whatever this intramolecular force will reduce and the space will increase. So after giving heat, the heat is absorbed due to kinetic energy, so the space is increased. And the force, if I move far from each other, see, like this, obviously my force is less, right? If I tightly pack, this is more force. If it is less force when compared, why? They are far from each other. Similarly, this happens. Why heat is transferred? Because molecules in the body will try to move because they absorb the heat and they get attain kinetic energy. Due to of the kinetic energy, they will move far from each other. Due to the movement of moving from far from each other, so what happens? The intermolecular force will be decreased and obviously the space will increase. Right? This is a way that heat is transferred from hot body to cold body. So in this only we had a question, why always heat is transferred from hot body to cold body? When compared to cold body, hot body molecule will have more kinetic energy. So they will be very active when compared to the cold molecules. Obviously they move fast when compared to the molecules in the cold objects. That is the reason always heat will transfer from hot body to cold body. Because when compared to the cold bodies, whatever the molecules will have high kinetic energy than the cold bodies. So if in the class there are two persons, they are very active, so obviously the person who is very active will move fast when compared to the lethargic person. In cold bodies, the molecules are lethargic when compared to the hot bodies. They are more energetic, they are more active. That's why they'll move far from each other. So by moving far from each other, by going, they'll transfer the heat also. They'll carry the heat and they'll distribute the heat to the cold body. That is happening in the heat. So now you understand what is a heat. It is a form of energy and always heat is transferred from hot body to cold body. And you know why it's reason now. Now, next we'll move to the units. So in physics, numerical alone will not give any meaning. We need to represent the units, right? And you know that we have SI system, MKR system, CGS system. SI, what is meaning of SI? Standard International System of Units. MKS, meter, kg, second, centimeter, gram, second. So we all together confirm this MKS system as a standard international system. So that's why MKS system or SI system will have similar units. That doesn't mean that SI is different from MKS. We all together confirm, yes, we will use the MKS system as a standard international system. Right. What is SI? Standard International System of Units. SI means Standard International System of Units. MKS. What is the meaning of MKS system means? Here M represents that meter. So V represent length in meter. K, V represents mass in kilograms. And S, time measured in seconds. In CGR system, length is measured in centimeter. Length is measured in centimeter. Mass is measured in gram. Time is measured in seconds. Right? This is the meaning of MKS and CGR system. So, mass, that is length, mass, time. Length is measured in meter, mass is measured in kg, time is measured in seconds in MK system. Length is measured in centimeters, mass is measured in grams, time is measured in seconds, that is CGR system. Now, in SI system, that is Standard International System or MKS system, the units of heat are joule. Joule is a scientist who gave the unit, that's why joule, and we represent joule as a capital J. When we represent as the units as capital J, when it is given by any scientist name. And in CGR system, the units of heat energy is calorie, right? Calorie. And even we have a relation between joule and calorie. 1 joule, 1 calorie is equals to 4.186. This is the relation between a calorie and joule. That means if I have the heat energy in terms of calorie, if I want to convert into joules, I need to multiply with 4.186, right? So this is the relation between the CGR system. So this is the unit in CGR system, and this is the unit in MKS or SI system, right? So these are the units. Now, how can I calculate the heat energy? So to calculate heat energy, we had a formula, that is heat energy. Heat energy. How can I calculate heat energy? I have using this formula. What is the formula? Q is equals to M into C into delta T. What is Q? What is M? What is C? And what is delta T? Here this triangle we represent as delta. Delta means change in the temperature. The Q represents heat energy. Heat energy is represented by a symbol called Q. M, mass. It is a mass of a body or a matter. C, specific gravity. So specific heat, and even we represented as S. So we can represent specific heat as C or S. Delta T. Delta T. What is the meaning of delta? Change. Change in temperature. Change in temperature. Right? This is the formula to calculate heat energy. Now, if I write the units for heat energy, mass, specific heat, change in temperature, later we will go for it. Now, you understand that? Formula for heat energy is Q is equal to M into C into delta T. M is mass, specific gravity. we represent S or C. And delta T is the change in temperature. Now here we need to discuss what is C, because C, specific heat, it is very new term to you, right? You know that Q is a heat energy and the units of heat energy is joule or calorie, right? We know in mass the units kg or gram. Temperature Kelvin or degree centigrade. But what about the specific heat? What are the units of specific heat? First, what is a specific heat? So this is a standard value for any substance. That means if I take water, always the specific heat of water is standard. If I take any another, think it is kerosene. Yes, kerosene will have specific heat, standard value. Wherever it is water, I need to substitute the value of specific value. It's a standard value. That value is found, how we are substituting this. So it is the value founded by experimental calculations. Now, so slowly, now we will discuss what is a specific heat. So we completed heat, what is heat, the units of heat. Now we will go for the specific heat. Think that if you want to buy any product, right? Think if I want to buy this, what I require? I require amount. For what purpose I'll buy it? To write, right? So this is a hint only to remember the definition of specific heat. Think that I require amount to buy pen, and for what purpose I'll buy a pen? To write, right? Amount required, you can add it, required. Amount required to buy pen to write. Now, specific heat. Specific heat. Right? Specific. What is the meaning of specific? That is very specific. I am very specific about my food. That means only I eat. I'll have some list that based on that list only I'll eat. Remaining I'll not eat. Those persons will say that they are very specific about their food. They are very specific about their dresses. That means if they are very specific about the color, combination, or maybe a model, right? Similarly, specific heat means every substance is very specific about the heat that they absorbs, right? Now, specific heat. Amount of heat energy. Amount of heat energy. So instead of amount, you can write it as amount of heat energy required. So up to here it finished. Amount of heat energy required for unit mass. Unit means 1. Unit mass to raise the temperature, of unit degree. This is called specific heat. How to remember? Amount of heat energy required for unit mass to raise temperature of unit degree. To write, right? Here, unit mass, unit degree. Right? Unit mass If I take mass in MK system, that will be 1 kg. Unit means 1. So I am not taking any system, that's why it is standard, that's why I am having mass. If I am taking mass, if in MK system, that will be kg. And unit degree means 1 degree, but it will be Kelvin, right? So now, similarly, I will define what is 1 joule, right? This unit is given by scientist. He need to define what is 1 joule and what is 1 calorie. What is 1 joule and what is see, these two definitions are similar to this definition. Amount of heat, energy required, amount of heat energy required for, instead of unit mass, write 1 kg. 1 kg mass to rise temperature, the temperature of, instead of unit, 1 degree Kelvin. Why Kelvin? Because the MK system unit of temperature is Kelvin. Kelvin. So Kelvin. Now 1 calorie. See, again it is similar. It is MK system. This unit is MK system unit, and this unit is CGR system. Right? Here mass is represented in kg. Right? Temperature is represented in Kelvin. Here mass should be represented in grams. So if I want to write the definition of 1 calorie, amount of heat energy required for how many? 1 kg or 1 gram? Yes, 1 gram mass. For what purpose? To raise temperature, of 1 degree 1 degree Celsius. What is this? C? Celsius. That we call calorie, right? So these we are very similar. Only thing is, when you are discussing about the specific heat, you need to discuss about the unit mass and unit degree, because we are not following any system of the unit. If you are taking joule, if you are talking about joule, so the MK system, so you need to particular about the units of mass and units of temperature in MK system. If you are speaking about calorie, this is a CGR system unit, so you need to particular about the unit of the mass in CGR system and unit of the temperature in CGR system, right? Once it's very easy. Yes, initially you feel very difficult, but it is very easy. So this is a trick to remember this definition. Amount required to buy pen to write. Amount of heat energy required for unit mass. So here unit mass is the pen. And what is the purpose of the pen here, right? And what is the purpose of the mass? To increase the temperature. And that means to raise the temperature of unit degrees. How much it will try to rise? Only to increase 1 degree, right? Not 2 degrees, 3 degrees, 4 degrees. So that means if I want to increase the temperature for 1 degree, how much of energy I need to spend for 1 kg mass? That is a specific heat and it is a standard. Okay. Now, shall we move to the next? Now, I hope you understood, right? Now, we will move to the next topic. So, from starting itself, we are saying that heat is transferring, And we also know that, yes, why is heat is transferring? Because molecules will get kinetic energy by absorption of heat. That's why they are moving. Due to that, the heat is transferred. Whether all bodies will transfer the heat? Yes, all bodies will transfer heat. But in same manner? No. There are different methods. We have three modes. We call it as modes. Heat transfer modes. Right. Now we'll discuss heat transfer. What is the meaning of heat transfer? Transfer of energy from one body to other body. So if I want to transfer heat, what is the meaning of heat here? Heat represents that heat energy. The energy is, what is the meaning of transferred? So moved from one body to other body. One body to other body. So this is always hot body and this is always cold body. Right? So we have three modes of heat transfer. One is conduction. So these are the new words to you. So listen carefully. Conduction, convection. No, it's not convention hall. Convection. Third one, radiation. So what are the three modes of heat transfer? Yes, three. Once repeat with me. Convection, convection, radiation. What is the difference between conduction, convection, radiation? Right? Conduction. Conduction. Right? What is a conduction? Daily in your home, your mother will give you milk early morning. Obviously, almost you people drink milk. How this milk is boiled? Have you observed any time in your home? Your mother when boiling the milk? If you are not observed, yes, after the class, once observe. So ask your mother to heat even not a milk, even water also, and beside her stand and observe what is happening here. Right? So to heat water, think you want to hot water to drink. What you will do? Obviously, what I'll do? I'll take vessel water. Yes, you take vessel. So what should I do for that? So I need to place on the stove. Right? I need to place on the stove. Yes, I know. I need to fire it also. If I just place on the stove, yes, it will not give any energy. I need to give energy. So by firing on, that is by switch on the gas stove, yes, you are applying the heat energy. And now it is an empty vessel. Now you observed that. Now if the vessel is hot, if you sprinkle water, have you heard the sound? Right? Even the water bubble will also evaporate easily, right? Yes. Now fill the vessel at 1/4 or half of that, enough. Now see, before water, how the vessel, when you are placing the vessel on the stove, it is cool. After on the gas stove, yes, after few seconds it became hot. How it is becoming hot? The heat is transferred, right? Now take the other condition that, yes, this is my gas stove. I had a tripod stand, right? And now I placed my, I placed my vessel. This is your first case and this is your second case. In which case the vessel become hot fast? Yes, obviously in the first case. Why it is not in the second case? Because the vessel is not contact with the fire. It is far from the fire. So it is difficult to get heat when compared to the first case. Right? Yes. Here, have you observed thing in these two cases? Yes. The vessel is had a contact with the fire. Here, the vessel is not having any direct contact. It is having any direct contact? No direct contact. Right? No direct contact. But here we are having a direct contact. Right? Now, if I pour water now, even after few seconds or few minutes, even water will also boil. And even here, it's very difficult. First of all, the vessel should increase its temperature. Then it should transfer them. What happens? See here, whatever the heat transferred from fire to vessel. So first heat is transferred from fire to vessel and from vessel to water. Whether water and vessel are in contact or not. Yes, even vessel and water is in contact. Now, if I am supplying the heat energy, this heat energy is transferred to the vessel. This vessel is, so this will absorb the energy. And again this vessel will transfer the heat to the water. And here we have contact, here also we have contact. Right? This type of heat transfer we call it as conduction. That means if the two bodies are in contact with each other, if the heat transfers takes place, that we call it as conduction. Right? That means for conduction we require the bodies to be in a contact. Here in the second case, yes, water is contact with the vessel, but vessel is not had a contact with the fire. That's why what happening? The heat is not transferring quickly, right? Yes, it may take a long time, may or may not. That depends upon the distance. But yes, there is no contact. Here there is a contact. Yes, what is a conduction? The heat transferred, the process of transferring of heat by direct contact. What we call? What is a conduction? Shall I rub it? Yes. Now, what is conduction? Conduction is a process of transferring heat through process of transferring heat by direct contact. By direct contact, we call it as heat energy. So that means if the two objects are in contact, if there are heat is transferred, then we call it as conduction. Right? So write a few examples where you observe that heat is transferred by contact. Yes, first one I discussed. What is the first case? If I put a vessel on the stove, the heat is transferred is by a mode of conduction. And even the heat transfer from vessel to water. From vessel to water, that is also conduction. If I drop a spoon into the hot water, after a few seconds, what happens? Even the spoon will get heated. That is also conduction. Have you observed that? If you touch the hot water glass with your hand, yes, What is that? You had a contact with the glass water. Yes, that is also conduction. Right? So now think, observe your surroundings and try to figure out whether heat is transferring. Yes, if the heat is transferring, whether it is conduction or not. Right? So try to write a few examples of your own for the conduction process. Okay? So I stated for a few examples, right? So you at least try to write 3 examples of the conduction. Now we will move to the next mode of transfer, heat transfer, that is convection. Convection. Right? What is another mode of heat of transfer? Convection. I made mistake. Convection. What is the other mode? Convection. Convection. Right? Yes. What is a convection? So before going to the definition, I want to explain by example. Whatever we observed in the first example, the first case, yes, after putting a vessel on the stove, the vessel getting heat up, whatever the water or any liquid or any solid substance in the vessel also get heat up by the direct contact, right? Now, if you try to place, so for a few minutes, yes, the water start boiling. Now, so if you try to place your hand on the hot boiling, so the condition is the water should boil. So don't put your hand for a long time. So for a few seconds, try to place onto your hand onto the water. What happened? Yes, first of all you feel that warmness, and even you can see that your hand will become wet, right? Why? Yes, whatever the water is boiling, the water is converted to water vapor, and the water vapor touches your hand so that your hand will become wet. Other thing, even the water vapor will have a temperature. For that, it will transfer to your hand. That's why you will get a warm feeling. If you place your hand for a long time, yes, it also burns your hand. Right? That means it is difficult to place. Right? Now, have you observed that whether I am having any direct contact with the boiling water? Whether I place my hand in the boiling water? No, right? I place my hand very far from the boiling water, but still I felt that warmness and heat, right? Why? Because the water vapor, whatever the water molecules are transferring from one point to other. So from here they are traveling to your hand and they are transferring your heat, right? This type of transfer of heat, we call it as convection, right? So now you understand what is convection. Now, so this happens mostly in liquids and gases, right? That means the process of transferring of heat in liquids or gases. So the convection that takes place in liquids as well as in gases, but the convection will not take place in solids. Why? The solid molecules will not move from one point to other point. So convection does not takes place in solid. That you need to remember, right? It happens only in solids and liquids. Now, what is convection? Process of transferring of heat by the by the actual movement of particles. By the actual movement of particles. Right? This is your convection. Like means here, yes, whatever the water molecules, they are converting into gaseous form and they are transferring from the point to other point. That molecules are moving, right? So actual, by the actual movement of the particles, that heat is transferred. Then that mode of transfer we call it as convection, right? Even if you had any cold, you will go for steaming, right? After few seconds, yes, your face will all starts burning. Why it starts burning? Because the heat is transferred to your face, right? Whether you put your face into the water, no. But why you feel that burning sensation? Because whatever the water vapor, they are moving from there to your face and the heat is transferred. That's why you are having that burning sensation. That means the particles are moving. Right? This is the convection. Even in summer, yes, cool breeze, hot breeze, even it will burn you, right? That means the heat is transferred by the molecules and they are traveling along and they are transferring the heat. So this is convection. So observe your surroundings and try to figure out the examples. 3 more examples. So observe your surroundings. Yes, whatever the process you are observing, try to figure out it. So now you understand conduction, convection. In conduction, particles will not move. They will be in the same position, but they are in contact. The bodies are contact, so no requirement of that. Have you seen that vessel melted and traveled? No, right? So they are contact with each other. That's why they are transferring the heat. Here, whether your hand and the vessel are in contact? No, not at all. Whether your hand is contact with the water? No, not at all. Then how you felt that hotness? Because the particles, water particles are moving and coming and they are transferring heat to your hand. That happening in the convection, right? So this is your conduction, convection. What is that? Conduction, convection. Have you understood what is conduction and convection? Now we will move to the last one, but not least one, radiation, right? What is a radiation? Radiation, transfer of heat, right? Radiation, right? When you early morning, if you go out, right, that means now only the sun is rising. Whether you feel very hot, yes, you will not feel hot. Think if it is 9 o'clock, 10 o'clock, 11 o'clock, then yes, you feel warm, not heat, you feel warm. 12 o'clock, yeah, very hot, right? Now, why? How you are feeling that difference in that morning? It's not hot. 9 to 10, it's feel warm. In afternoon, hot, very hot, right? How? Who is transferring? Is there any medium there? No, right? Here, the radiation. Best example is sun. What is the distance of the sun? Yeah, it's very far from here. It is in lakhs. So obviously sun is not nearer to me. From sun and your earth, right? And you are on earth, right? Chalo, not you? Okay, think it is me. So around the, we will have atmosphere, right? And apart from atmosphere, what is this? Vacuum. What is the meaning of vacuum? Nothing is there. Empty. Right? Empty space. No gas, no solids, no water, no liquids. That is called vacuum. Here there is no. When the sun is contact with you now, no. Here it is vacuum. Whether the particles are moving, no. Then, but still, you feel, you get the sun rays, and along with the sun rays, you will get a radiation also. That means slowly the heat will be increased. Yes? This is called radiation. That means the process of transfer of heat without any medium. No any mediator, we don't require any mediator. Whether we require a mediator? No. If there is mediator, if there is no mediator also, the heat is transferred. Right? So what is a radiation? Process of transferring heat without any medium. That means there is no requirement of contact between the two bodies. We don't require any particle movement. Still we will get heat. That is called medium. Process of transferring heat without medium from one point to from one point to other